A-scan is time amplitude. Time is along the bottom, and amplitude is vertical. It gives you a bunch of lines, and those lines define how strongly the echoes are displayed. If you'll contemplate an A-scan probe on the front of an eye, just as if you were going to make an axial length measurement, you would get back one A-scan, usually demonstrating the front and the back of the lens, as well as the beginning of the retinal spike. Those would be 3 vertical lines. But how can you make that into an intensity-modulated system, a B-scan? If you move the probe up and down the eye, maybe 125 different places, and took an A-scan from each one, and then carefully picked them up, turned them 90 degrees, those lines would come forward enough to cause the phosphors on the front of a screen to glow, and they would give you 3 dots. Connecting the dots would basically give you a B-scan. One further point. Often when you're in simultaneous A-scan, B-scan mode, you will see a vector line across the screen. That vector line actually represents the one A-scan in that site at that position that is displayed at the bottom of the screen. With simultaneous A-scan during a B-scan, you can tell whether or not you're perpendicular to an object that you're trying to follow. And quite frankly, it is easier to measure the height of a returning echo in amplitude than it is to be able to discern a difference in its brightness.